The topic I'll be discussing today is OFDM, that is orthogonal frequency domain multiplexing in 5G. So in 5G, our major goal was to achieve increment in data rate, and in order to increase the data rate, we can either increase the bandwidth or efficiency. With the increment in bandwidth, there comes a problem. So before discussing the need of OFDM, I'll be discussing a problem that is ISI due to multiple path propagation. ISI is inter-symbol interference. So in wireless communication, signals reach the receiver through multiple paths, and this multiple path propagation is because of the reflection either through buildings or from ground or from any kind of obstacles. And due to this multiple path propagation, different symbols do come at the receiver side at different rate, and they do overlap at the receiver side. And due to this overlapping of the symbols at the receiver side, we have this issue called inter-symbol interference at the receiver side, due to which the signal do get distorted or disrupted. And in order to deal with this problem, we came up with a solution that is OFDM. In single carrier, the entire signal was transmitted on a single bandwidth, but it was difficult to transmit a signal on the single bandwidth due to the channel equalization and estimation issue. So what we did in OFDM was, first of all, what we did in FDM, traditional FDM, was that we divided that single carrier into multiple subcarriers, and to prevent the inter-symbol interference, we implemented guard bands in between those carriers so that these carriers do not interfere with each other, and the inter-symbol interference is solved, and we were able to deal with the issue. And in further optimization of FDM, we came up with OFDM, that is orthogonal frequency domain multiplexing, in which we divided the entire carrier into multiple number of subcarriers, but here we removed the guard bands which are present in traditional FDM. And it may appear in this image that these subcarriers are overlapping with each other, due to which the ISI is not dealt, but it is not true. All these subcarriers are actually orthogonal with each other. Since they are orthogonal, so they cannot interfere with each other at all at the receiver side, and because of this no interference at the receiver side, the ISI issue is actually dealt. So this is actually the magic of OFDM, where the subcarriers are actually orthogonal, and the formula for orthogonality is thus that the signal S1t and the signal S2t and the product of their integration is actually 0. And with this orthogonality, we have solved the ISI issue. So this was the major need of OFDM. And so what happened with OFDM, the another one advantage is that as we have divided the entire subcarriers into multiple subcarriers, so we have divided this large bandwidth into small bandwidths. And since the bandwidth is reduced, we can increase the symbol rate. And since the symbol rate is increased, it means that the symbol can stay on the receiver side for large amount of time. And due to this large amount of time, the interference issue is automatically reduced. So this is how we reduce the ISI. Now I'll be discussing about some of the advantages of OFDM. So first I'll be discussing the channel model, that when a symbol X is transmitted over a channel having gain H, and N refers to the AWG and noise, and Y is basically the output that we do get after transmitting the signal over the channel. In single carrier, the bandwidth is so large that it is difficult to estimate the value of H, because the value of H is not at all constant for the very large channel. So in OFDM, since we have divided that large channel into multiple subcarriers, the value of H for these multiple subcarriers can be constant, since the subcarrier has less bandwidth in compared to the single carrier. So in OFDM, it is possible to equalize the channel. Equalization is basically the concept in which we try to reduce or remove the impact of the channel at the receiver side. When a signal travels from the channel, it does get disrupted or amplified or attenuated due to the channel gain H. So when it reaches the receiver, we want to remove that channel effect from the signal, and to remove that channel effect, we need the concept of equalization. The equalization is not at all possible in single carrier, but in OFDM, due to presence of subcarriers, we can easily equalize the channel. The another advantage is channel estimation. OFDM uses pilot symbols to estimate the channel gain, and at the receiver side we do calculate the value of HI by using YI divided by XI. So this is how we do achieve channel estimation as well. There are other advantages: accommodating multiple users. In OFDM, since channel equalization and estimation is possible, we can very easily detect which of the subcarrier is a bad channel, or which of the subcarrier do have high SNR, or which of the subcarrier do have low SNR. And based on the requirement of the user, we can assign different users on different subcarriers, and if the channel is bad, we won't assign any kind of user to that channel. So this is how we do achieve the multiple user accommodation in OFDM as well. And the use cases of OFDM are Wi-Fi, 4G LTE and 5G NR. And this was all about OFDM. With this I'll conclude. Thank you so much.